Hey, there we are.
Yep.
Okay.
About the testing. There we go. Tomorrow is a noteworthy day for me. Well, actually, I guess Sunday. It's the day when I take all the food from my freezer and restock my fridge. I'm excited.
Okay.
Fresh start.
I'm just trying to make conversation. Don't worry about it.
I guess tomorrow is less noteworthy because my family comes back.
Doesn't affect my noteworthiness. Sorry about your
Wow.
noteworthiness, though.
What's the theme today, Thomas?
We're going to talk about sequence diagrams. Okay.
So I didn't really need a UML diagram for something I was playing around with this week. But when I tried using Visual Studio, I was struggling to get it to create a new class from the class diagram. I could pull in old classes, but I couldn't seem to get it to like create a new class from a diagram, which was unfortunate.
It looked like
We're
it might not
recording
be,
already. That's weird.
yeah. It looked like it might not be true UML because I wasn't seeing a way to create relationships between them. And
Yeah.
now I did see that there are plugins for Visual Studio that allow you to create UML diagrams, but it might be that we need to find a plugin rather than use I forget what it's called, class creator, class
Diagram.
diagram. Yeah, it looked like that wasn't true UML.
Because I didn't need it, I didn't dig for it too quickly, but it was just sort of annoying that it wasn't quick and easy to use.
Class diagrams are class diagrams, and UML does include class diagrams, but Visual Studio would be like for visual way of actually making classes, right? Like that's all it's for. It's not a documentation solution for discussion for things the way that a UML tool and such is. So I don't use Visual Studio for that. I never have. It's an option for you, and the code back and forth is nice, but you can't do the UML. Anyway, so this week is going to be a lot shorter than last week. I'm going to focus on one thing, and that is on sequence diagrams. And I don't know if you've seen sequence diagrams before. And then I think that I don't think there'll be time to talk about activity diagrams, but those would be the three things that are important: sequence diagrams, activity diagrams, and class diagrams. I started with class diagrams last week. I use sequence diagrams for the exact same purpose reason that we talked about last week is it aids thinking. So anything that can aid thinking is a good tool. It doesn't matter the tool. If it helps you think better, then it's a good tool. And so sequence diagramming was created to help think through the problems that you have in doing software development, which is, what are all the methods that I need? So we talked last week about, you have this class diagram, you look at your classes, and then it's like, okay, that's great, but what do I actually do with it, or how many calls are there between this thing and that thing? How do you answer a question like, do I need visibility between this class and its, say, parent class, or parent isn't right because that implies inheritance, but the containing class? Does the little data class need to be able to see the container or not? How do you know how to answer that? And most programmers, everyone at some point would say, Yeah, you know when you need it, and you just, oh, I need that, and then you got to add a reference and whatever and stuff. So I'm going to show you today is the way that you can figure that out without having to code anything. And so whereas the class diagram allows you to go, and it's exactly what I did. Like, I'm trying to be very practical on these things. I was working on how do we represent narrative for True Play, Ava, Maple. Mark had listed out a bunch of needs, requirements, something like the character has a certain color, say blue. But for this particular line, I want to override that. Well, somewhere has to store what that override color is, and where does that override color go? Like, it's maybe obvious it's on the line that's being overridden, but anyway, so that's what the class diagram does. It's like, this is all the data that I need in order to solve that. And I went through, after I'd done my class diagram, I went through and I double checked all of his requirements again, right? And so I'm reading his basically story, right? His user story. I'm kind of reading through that and going, yep, okay, that's here. Yep, that's there. Oh, I missed that one. Okay, I got to add my thing, right? And so in a sense, I don't ever need to look at that again, right? Because I know that my class diagram has everything that I need. And so you could, or maybe we would think, okay, generate classes and let's go. Let's start programming. And the answer is no. You can go another step further, which is the sequence diagram, to figure out the relationship between systems and classes and the methods that are necessary between them. And so I haven't done this for a while. I did it a tiny bit today while I was in my agile training meeting to make sure that it works. So it does work, but I might fumble around a bit in this thing. So that's kind of the preamble. So I'm just going to start a new class diagram. So back to White Star UML. Michael, did you pick a tool that met your aesthetic needs? You're muted.
I didn't give that a chance. I tried with Visual Studio, didn't get what I wanted from it, and didn't have time to really dig into it further because I didn't really need it for what I was doing. So I was just trying to push forward. So haven't played around too much.
This to me is the big advantage of the tool, right? So class diagramming. I showed you in Visual Studio, you can do class diagramming, right? And we're done. You can't do what I'm about to do in Visual Studio. And there's way more that this software does to help with design and programming. And so that's why you have the specialized tool. So I'm using this as an example, and I think I might pick Tyler's brain for doing another example, but we'll start with this because we're dealing with narrative. So this is the class diagram. I have it laid out as Josh was referencing. I have the associations between it. So a script has a scenes container, right? You call it a list, but we're being more generic than that. So it just contains a bunch of them. And how many scenes are there on a script? 1 to star, which is many. Star is just many. So it's 1 to many. What this means is a script is invalid if it doesn't have a scene. That's what that means. So theoretically, every list, every array, everything can have 0 entries in it. That's how it's initially made, right? You initialize it, it has 0 entries, right? And so what the diagram is telling us is it's not valid yet. It's going to break, it's going to blow up, it's not going to pass assertions or whatever if we don't have at least one thing in it. And so a scene has to have at least one line in order to be valid. And a line has 1 character, not 1 to many like these other ones. It just has 1. It can only ever have 1. And so that's very clearly stating that it's not a list. And then this is where Fred Brooks talks about turning something into a product, like the 4 quadrants of things. And it's always harder to do things more generic and more productized and such. And so this is where you're at the point where you're like, oh, if I want to turn this into a multiplicity, right? So from 1 to 1 star, like I just added cost to the project by doing this. And I now know, oh, I need to do this as a list, not as a single thing, just with that one simple change. So anyway, what this is communicating is it's one. There's one character per line, and there's the lines will reuse characters, right? So character will have many lines will reference character, but character will only have one. Line will only have one character, but character will appear in many lines. That's what this is saying. Okay, so like I said, we haven't done a whole lot yet, but the next step is, okay, how does it actually work, right? I got this thing called a script player, which I pulled out. Zach may remember it. So I went and looked at the code from some of the stories, and the script player. And the script player, what does it do? It plays a script. Okay, so how does it do that? Like, I know it needs to do that. That's the thing. I was just finished the agile training session with the leads, and they're saying all the right things and all the things that need to be done, which is we got to write epics, we got to have stories, we got to have stories broken down into tasks, which they call grooming, and decomposing things into individual tasks, and those are estimated. And so at any given time, the CEO, head of product, whatever, can take a look and say, how much work do we have in the backlog? How much of it requires engineering? How much of it does requires art? We should be a data-driven company. TruePlay should be a data-driven company. And so that decomposition of things requires estimating. Well, how do you estimate just based on a class diagram with a bunch of data? You can't yet, because you don't know how much work you have to do. And that's the next step of figuring out all the methods. So the way that you could figure out the methods, as much as you could figure it out before you're programming, right? I'll totally give you that caveat that you can only go so far with the diagramming, where you have diminishing returns. But the first hour you spend in this, or the first half hour you spend in this, you get a lot. What is everybody chatting up a storm here for? It's on. I don't know what's going on there. Okay, so. Then, the third hour of diagramming and sequence diagrams or whatever is really diminishing returns. You don't need to do that anymore. So we need to do this in order to estimate how long this particular task or story is going to take, so that they can see it in their system and answer questions for Brent. I think the big thing that with Brent is, like, he pushes for things, and people say that's not possible, and he's like, okay, why not? And they, like, it seems to fall apart there, right? But if they can, like, unified bring out like a report that shows, yeah, these are all the things, and this is why we can't do it, it seems like he's a reasonable guy that would go, oh, okay. But if you don't have the report and you don't have any data, then it's just opinion. It's like, you say you can, I say you can, go do it. So that's, anyway, what we're going to do. So we go here into we go over here, and we go to add a diagram, and it's a sequence diagram. So sequence diagram, okay, so it's blank, it doesn't have anything. So you can use this completely blank. You start throwing down objects, and I don't know why they don't begin with Korean names, but they don't. So you start slapping down objects, and off you go. But the other more useful thing is you take the work you've already done, and I already know there's a script player, so I drag it in, and I know that there's a script, and there's a scene, and there's going to be a line. And I'm going to do this very roughly, and we're going to see how these things interact. So I'm lining them up. I don't know why they're not automatically lined up. There's probably some key for that. Okay, so stimulus is everything in software is a conversation. That's why use cases are written in a dialogue format, which is user does blank, system responds with blank, then user does next thing, system responds with next thing. That language, when you write things out that way, maps to this. That's why you write it that way, because it maps exactly to what we're doing here, which is, okay, so the system has some kind of stimulus coming in, and we want to play a script. So we want to play a script. We're just assuming that the script player is an object that already exists. So I drag this thing over here. And when it pops up, I choose this and I choose the operations that have already been defined. And so I say, okay, I want to get a scene, and I can define the parameters on it. And the parameter would show up in here, right? They call them arguments. And that would be a scene ID that I want to get. So script player is like, hey, script, I want to get a scene and give me back a scene. And there's ways of showing like the return results if you care about that, which is down here. So we can. So there you go. Now it's showing like what you're actually getting back from the thing. So, okay, so what does script do? Well, script needs to do some stuff, and we only have two things that you can do: stimulus outside, which is calls outside of the class, and self stimulus, which could sound rude, but self stimulus is just calls inside the class. So this is where you go, oh, this can be private, and so I don't even know if I have. Oops. So you just okay, and do I have anything on here? I just have get scene that's currently defined. So let's say for whatever reason, for good housekeeping, we're going to put in start first scene. Actually, that would be a mistake. Let's not do that. So every time you're modifying your what do they call it, logical thing, anytime you're modifying anything, it's creating things over here. So I don't actually want this, and I hit Control Delete in order to get rid of it, and then it's gone from here. If you just hit delete, it removes it from the diagram. It doesn't remove it from your model, and that's super important. The difference between diagram and model, because you can have 50 methods modeled, but in your diagram only show 3 of them, right, for clarity. And so Control Delete is removed from the model, I don't want it, and delete is removed from the diagram. Okay, so we get our scene back, and then now we want the script player to actually run the scene. So from the same instance, so I'm dragging this out and pointing at the thing, and I'm going to say start scene. Okay, so we got starting of the scene, and it's attached here, and this is now showing how long a reference is living. So this is showing lifetime of an object, and this gives you a visibility into how many calls am I going out? Maybe even by looking at this, you can see, wow, I'm generating like 6 objects in this. Is there a way to reuse that by changing the order of operations so I don't end up creating garbage and garbage collection and such? So that's what these lines are, the lifetime of the object, and it'll automatically add to it as you add these. So now from within the method on script, I'm going to go over to the scene itself and tell, I'm pretty sure there's something wrong here. Okay, figure out what the next line is. Actually, that's a bad idea. Change that. So start the scene. So we're going to do start, and within start, we're going to figure out what's the next line, right? Because that's what I really need to know in order to start seeing what's the first line, right? And so I'm going to call next line, and then next line. I don't even think there is anything on here. No, there's nothing on there. Maybe it has to go and tell it to initiate. So I'll just pretend that it does, and say. Call the init method on there. So the reason you're using this tool is if I go back here, look, here's the init thing on here, right? So all your diagrams are automatically updated, and that's why you work in this model view way, right? If we were in Visio or just any other kind of UMLing tool, all they know about is diagrams. They just have the pretty arrows and whatever, you can move things around, but they don't automatically update. So if I go back to my sequence diagram, I'm like, it's important to me to start putting in parameters for this. What are the arguments for this thing? And I start typing them in. So they're going to show up over here on my diagram. Okay, so after I've started the thing, then the script player, it needs to do a bunch of things. And so these are all self-references, and so I'll just say set background. Display character.
The self-references, they're basically the object calling its own, some of its own state, like whether it's a method or a private variable or whatnot.
Not private variable. We're only talking about methods here. This all sequence diagramming is verbs of methods.
Okay.
Um,
Not including properties, just methods.
yes.
Yeah. Properties are both fields and methods. So
Yeah.
I don't really want to get caught up in that. Like, which is it? Whatever, you can put a get or whatever at the beginning. It's pretty clear it's a property. But so we're setting the background, we're displaying the character, fire, music, or I won't put that there. I don't know, like, I'm not doing good design here. I'm just trying to demonstrate the process. So let's say when you're displaying the character, when you're setting the background, there might be music defined on it. And so we're going to go to the script, and why we have a script player is to keep these classes kind of like data classes. So they don't have to know all the references out to all the rest of the game in order to be able to do something like, does the line need to know about master audio and how to make calls to master audio? I'm saying in my design, no. I mean, you could make your own design and argue, yes, that's the difference in programmers and how we approach things or whatever. There's just different ways of doing it. But anyways, I'm trying to keep these data classes or entity classes strictly to the data. And so, but anyways, for whatever reason, I'm like, hey, when I set the background, there might be some music that needs to queue up and play that music. And so I'm going to go to the script and play background music. What you don't show in these diagrams is like all the if conditions. And so we're just mapping out one path. So I've spent a lot of years in my life doing UML diagrams, and that's because we were sequencing out the happy path, sequencing out what if there's an error, sequencing out what if the customer's credit card gets declined, sequencing out what if the delivery window gets filled, and showing all the calls that are then done from that. So you don't have if conditions because you already know what the path is that you're mapping out. Now, I never expect to do that level of detail again. I'm not asking you to do that level of detail. I think it's onerous and unnecessary. Where it is necessary? If you're outsourcing to India, because they are only going to program what they see in front of you, right? They're like, hey, I just did what you told me to. Like that approach, I don't hire people like that. I don't expect any of us to work that way. Like, you get it. This is the happy path. Awesome. And you can figure out your exceptions and exception handling from there. So anyways, here we go. We have play the background music. And so I can show, like, is this a new instance of that thing? No, I'm reusing the same object reference. It's just staying alive for this thing. And this thing over here is supposed to have a big long thing beneath it, and I don't know why it's not. But anyways, it's supposed to show like the script player is alive throughout the entire thing. It's not suddenly coming into existence, going away, and suddenly coming into existence again. I might just be able to do this, but no, it won't let me because it can't be instantiated before it's called. Anyway.
I have a question for clarification.
Yeah.
Like these yellow bars, are they maybe not like so much the existence of the object, but rather like the runtime of the function, right? So like for the scripts, like get scene, and then you have the big long yellow bar. Is it then like everything exiting, every arrow exiting that yellow bar is something that's being called from within the get scene function?
Yes.
Or is
right.
Okay.
Right. That's how it is.
Okay, and so then kind of a bit of a clarification again on, say, get scene and start scene. Like, I'm assuming time is moving from top to bottom as things are happening.
Correct. That's
like,
why they're numbered in sequence.
Okay, and are these like get scene is going to be called, if get scene is called, then do this? Or is it like get scene is always called followed immediately by start scene, followed immediately by set background? Like, is there some sort of overarching main function that's going to be like get scene, overarching main function that after get scene, it does start scene and
Yeah.
something like that?
I didn't show the stimulus coming in because it needs something. I need an actor or something here to show the initial stimulus coming into script player. I just started from script player.
Okay.
So
Okay.
see why that's confusing. But you're 100% right. What are we doing here? We're creating in design time the stack trace of what it is that you're programming, right? So
yeah,
that's why this is so great, because now I'm not surprised by the stack trace because I planned it out, right? The way we program right now is we write a bunch of methods and then we look at the stack call list to see what are all the things that are happening. And so this is doing it properly and upfront to see this is the call stack. So it's automatically numbering them for me, right? I'm calling get scene, then start scene. And what happens next? Set background? No, even though that's the next line in the script player. No, what actually gets called is start and then next line and in it, and then we go back.
Are you sure the numbers aren't just what order you created them in? Because it seems like it's saying set background runs the then init, then play background music, then display character, and that's the order you created them in.
It shouldn't be. I'm not sure actually why that is, but it's supposed to be numbered in the sequence of the calls.
I think they're actually on the same line in it and set background.
Could be.
Yeah.
Okay. So if I move this down, that is possible.
Yeah.
Yeah, that's why. So I just got to draw better. Yeah, so this has to be there. Yeah, so it's looking at the Y in order to determine the sequence. Okay, so the sequence diagram now, as a programmer, when you're given this and you're given this, hey, this is the thing, right? And you're like, oh, okay, oh, I see these methods. I don't really know what these methods do. I just know they exist. So now when I'm estimating, I'm like, okay, well, let's assume that I'm done. Like the design task is done. I'm like, oh, okay. Zach, how long is it going to take in order to make this? And you're like, well, there's 5 methods, 7, 8 methods. That gives you something to work from. Not all methods are equal. We do not have a rule of thumb of one method equals 1 hour or like anything like that. But it's way better than just reading a half complete design doc or a use case scenario and reading that and going, I don't know, right? And then like when I get into it, then I start to figure that out. This is the getting into it aspect. And so I've now fleshed out this class diagram a bit more. And if Zach was estimating, he has this now too. Right? You can start to see the complexity and the interaction of the objects. And so this is where the UI manager and the game controller and the state game state manager, where like these objects should exist in the model here. And then you can start referencing them and you can start to see, the calls are already there and you just like make the call. Oh yeah, I should call that thing, right? And you're just really thinking through the whole thing. Now, what I said is probably get you thinking, wait a minute, are we going to share these documents and models across each other so that way, somebody types out all the methods that are on the game state controller, like so it'll appear in mine. Ultimately, that is where one can get, where you have this kind of documentation library of like this. The model contains all your documentation, and you're able to do that, or you can read in source code and such. Again, just trying to focus on the socks and the basics. If we're planning out our work with the sequence diagrams, we're already like pretty far ahead of where we currently are. Thoughts, comments, complaints?
Makes sense. I guess one question is like, is this exportable as well, or is this something that you're gonna have to recreate in this classes?
That is a good question. Stored under. They always have different words for it. I forget what this is stored under. It's in the design model. Okay, so I think that's what that is. And I'm going to see what I got. You won't be able to see it because I'm only sharing one screen. It created the methods. It did not create the calls of the methods. So on script, I have get scene and start scene. Go to script player. Yeah, script player just generates the methods, but it doesn't make the calls for you. I don't know. Maybe there's an option for that. Maybe if we got the paid version of Star UML rather than the free version of White Star, maybe they do that. I don't know. That's an interesting tool question.
So I'm trying to figure out what the main question that this diagram is trying to solve or answer. Like the class diagram makes sense. I'm like, hey, we need to, here's how these things relate. This seems like it's almost like pseudocoding, but I don't know. Like if you're not going through all the cases, I guess I don't know.
So yeah, it's pseudocoding. And the reason you pseudocode is because it's low cost, highly, it's fast. It's fast to work and iterate and low cost in terms of change. You could pseudocode in Notepad and write out like these are the sequence of things that I'm going to do. I find that's way better. When you're dealing with a lot of systems, like I used the example of the game controller and the UI manager and such, I want to know, like, when am I calling those things and should I and such. So as I'm going through this, I am thinking about, okay, I know that I have a character that I need to display their name. Like, when am I displaying the character? Well, I got to change the background and the music first. That's valuable to think that through, right? Because maybe I would think that I'm going to display the character and then I'm going to change the background. And so by sequencing it out, you discover some of the bugs, in a sense, the deficiencies or defectiveness of your initial idea by going, wait a minute, I shouldn't display the character until the background is already loaded on the screen, right? So it's the thinking it through part that should be helping in answering the question. Whenever I am programming, you're always guessing as to, like, what should come next, what should come next, what should come next, and that's what this is doing. What should come next, but then giving you something you can validate against. So I can now go back, look at Mark's document and look at the methods that I have, or look at this and make sure that it's going to jive with the pictures that he's provided or such, right? So does that answer your question? Because I think there's a second part that might answer your question.
So, but you can do the second part.
Okay, so the second part is when you're integrating with systems, and you need to know which systems. So we use Tyler as an example for everything. And so Tyler's working on the build thing, and he has Unity that he has to talk to. He has Xcode he needs to talk to. He has Git that he needs to talk to. And so each one of those things, right, can be represented here. Xcode. I need to make a call to Xcode. I need to make a call to Git. and what is the sequence? What are the things that I need to do? And so you start drawing out your lines, and then you start to see, oh, okay, these are all the calls that I need to make to Xcode. Then I need to do something with Git. Then I need to go back to Xcode, and it helps you think it through before you start writing bash scripts. Because when you're doing, after you do the sequence, go back in and start putting in the parameters that you're going to need, right? So what do I need for get scene? I need a scene ID. Okay, well, how do I know the ID? And then you're like, oh, that had to be passed in. Okay, great. Now I got to go like make sure it's being passed in, and like that's where you start to discover these things. And so, using the building example, you might be like, oh, I got to pass this parameter to Xcode. I don't have it. So where do I get it from? And that's the thinking it's supposed to bring out, rather than the actual doing it, oops, try again, doing it, oops, try again.
Yeah. To me, this looks like it's a good tool for more of a big picture overview. Right? Like when if I'm like writing out a specific function, I might not realize exactly like what else could be using that, or what else further down the road I want to use it for. And so sort of sequencing it out like this kind of would help, like, oh, I have to make sure I set it up in a nice way so that I can use it for this, because it's going to be used for this. Exactly. So that's how I would look at like what this is trying to answer.
Yep. There's performance improvements that you can make at this level by looking at something and knowing that something is, a for loop. There's a while loop in here of 1,000,000 rows, and you know that, and then you're like, oh, actually, if I move this call out of here and up to here, then it won't be called 1,000,000 times, and it helps to maybe spot those things. When you're on a black screen coding text, it's far less obvious because you're down in the weeds. You're in the detailed mindset instead of the high-level overview mindset.
Yeah.
So if you're asking, do I have to now draw out every single method call? No, it's what Tyler said. It's a high-level overview of like, oh, this is the interaction between these things. What does a line do? What does a line do? What does a scene do? What does a script player do? And I made the decision that the script player is the thing that knows about the game and Unity and such, and it's going to make all these calls. So you know what I'm going to do? I'm going to go through and have a whole bunch of these self-stimulus things going all the way down. And it's going to be really obvious that I was like, oh, wow, look at script player. It does everything, and these things don't do anything, right? It's my paradigm is obvious. And so maybe I'm like, well, that's pretty lousy encapsulation. Maybe I should change my paradigm. Would I realize that if I was in Visual Studio and just coding? I would say probably not. Maybe, but probably not. And so it's a little more apparent here.
Okay.
Okay, that's all I have for today. I told you it was going to be a lot shorter. Nothing here for James or Ruby. Cool. Okay. Good CodeCraft. See you at the next meeting.
Okay.
In 20 minutes.
Yeah.
Yeah.
Bye.
Later.
See ya.